Imagine looking back in time to the universe's very beginning. The cosmic microwave background, or CMB, is our oldest baby picture of the cosmos. It's the residual radiation from the Big Bang, a faint glow of heat filling all space. It's literally the afterglow of creation. For the first 380,000 years, the universe was too hot for light to travel freely. CMB marks the moment it cooled enough to become transparent. This radiation is incredibly uniform across the sky, with a temperature of just 2.7 Kelvin, a few degrees above absolute zero. In 1964, Arno Penzias and Robert Wilson, using a horn antenna, detected persistent, unexplained static coming from all directions. They tried everything to eliminate the noise, even cleaning out pigeon droppings. But the hiss remained, no matter where they pointed the antenna. Meanwhile, Princeton scientists were theorizing about residual Big Bang radiation. A phone call connected the puzzling static to this cosmic echo. This accidental discovery provided strong evidence for the Big Bang theory, transforming cosmology from speculation to a robust scientific field. While mostly uniform, tiny temperature fluctuations in the CMB reveal the seeds from which galaxies and galaxy clusters eventually formed. Analyzing CMB patterns allows us to precisely determine the universe's age, 13.8 billion years, and its composition of normal matter, and dark energy. CMB measurements confirm that the universe is geometrically flat, meaning parallel lines will always remain parallel, not converging or diverging. The CMB acts as a cosmic time capsule, allowing scientists to study the conditions of the early universe, just moments after the Big Bang. Missions like COBE, WMAP, and Planck have provided increasingly detailed maps of the CMB, refining our understanding of cosmic evolution. Scientists are now studying the polarization of the CMB to look for signatures of gravitational waves from the inflationary period, just fractions of a second after the Big Bang. CMB data helps constrain models of dark matter and dark energy, the mysterious components dominating the universe's mass and expansion. Future experiments will continue to probe the CMB for even fainter signals, potentially revealing new physics and deeper secrets of our cosmic origins.